Okay, on page 210, the last day we're doing conditional probability, and we stopped here. Okay, so I'm just going to read through this and explain what this means. So if A and B are two events, the conditional probability that A occurs given B has already occurred is written like this. So this means what's the probability of A given B? And if it was written the other way around, it would be B given A. So it's read as the probability of A given B. So the probability that they wear glasses given that they're a girl, or the probability, like the question we had yesterday, the probability that it's prime given that it's odd, something like that. Find the probability of A given B. The sample space is reduced to B only. So it's only out of this, and then at its A, it'll be this out of the whole lot. So there's a formula here that you'll need to take down and remember. You'll come back to this when we do probability again next year. The probability of A given B is given by this. The number in the intersection over the number in B. So the probability of the intersection divided by the probability of B. Take down that and take that. Well, no, don't need to take down that. Just take note that you need to remember this. So when you think about it, A given probability of A given B. So it has to be out of this. You're given B and it has to be this section. So it's this out of this, and that's what they're saying. The intersection out of the whole amount. The result can be described as words. The probability of A given B is the probability of A and B divided by the probability of B. Now also, we'll use this formula to rearrange it. The rule known as the general multiplication law, which we'll use in book 5. The result. So we'll use this a lot in book 5. The probability of A given B is this. But if you were, say, looking for the intersection, which we will do in one of our examples, you can rearrange it and multiply this up here. And that's what they've done there. And similarly, A intersection B, it's the same thing, okay, if you were looking for the other way. Alright, so take down that yellow box, take down this yellow box that had been written the other way, and I'm going to do a couple of examples with this notation. Alright, and you might actually also, just while I spot it, also take down this. If A and B are two events, the conditional probability that A occurs given that B already is written like this. So take down this little section here as well. Alright, and then we'll do the two examples. Okay, first one. Probability. So this is the first example. This is the one. Well, it's example 3 on page 212. We stopped at the last day. So it says the probability of A given B. So the probability of A given B, like we said, if you go back to that yellow box I got to take down, it's the probability of A intersection B all over the probability of what you're given B. So it's this part. So it's 0.1 over the total probability of B. It's not 0.3, it's the total 0.4, which is a quarter, 0.25. The probability of B given A is the probability of the intersection over the probability of A. Because you're given A, it must be out of A, and it's the probability that it's also B, so it's this one. So again, it's 0.1 out of 0.5, which is 20% or 0.2. Okay, like you don't necessarily have to use this formula if you can see it from there. But here's the next one is where you do have to use the formula. So it's example 4. It says probability of A is 0.7, probability of B is 0.4, and the probability of A given B is 0.3. That's going to be 0.3. Find probability of A intersection B, and then fill out the Venn diagram. So we know the probability of A given B is the probability of A intersection B divided by the probability of B, because you're given B. And we want to rearrange that to find A intersection B. So the probability of A intersection B, this just comes up, is probability of A given B times by probability B. And that we've got those two amounts. Okay, we've got A given B is 0.3, probability B is 0.12 or 0.4 even. I'm writing down the answer already. Equals 0.12. So now we can fill out our Venn diagram. if this is 0.12, the intersection, this here is not 0.7 anymore, it's 0.58. And this is not 0.4 anymore, it's 0.28. And that adds up to 1. No, it doesn't. So there's obviously something on the outside. So if I add up 0.58 plus 0.12, that's 0.7 plus 0.28, that's 0.98. So we're missing something out here. It's 0.02, 1 minus 0.98. So where we use this formula a lot is when we're given stuff like this and you see this symbol, it's a straight line. It's not like, remember we did sets and we did A take away B, really. Everything that's A would not in B. Okay, but it's not that. It's a straight line down and it means A given B. So when you see that and you see this and you're asked to find intersection, just think you can rearrange that formula they ask you to remember to find whatever you're asked, really. Okay, so take down that. I'm sure I'll get a couple of questions on this because it is new notation, and any questions, just send it through.